Hello, everybody. Hello, friends. Hello, world. Hello. Welcome back to my YT channel. This is again, I'm singer, eternal voice. Oh my gosh. Look at my shirt. Alam niyo na what this means. Okay? So, we have our topic for today is, again, still science vlog under chemistry. Okay, so we'll be talking about oxidation state and a little bit of, rare and unusual chemical reaction. Unusual meaning it is not really explained very well and it is taken for granted. Something like that. Because it's not normally, used in the classroom instruction. Okay? So typically, things like this are normally subject for questions, examination questions, something like that. Okay? Okay, let's go directly to our problems here. So, three problems. So, can you see the board? Right? Mga palangga? Claro, di ba? Okay. Oxidation state is simply equal to oxidation number. Okay. Number one, calculate the oxidation state of sulfur in HSO4 negative. Okay, this is gonna be bisulfate. Okay, so it's very clear that this is a polyatomic anion because there's a negatively charged ion at the top, which is negative 1. Okay, if you find compound something like this with a negative charge and ions, so automatically we judge them as polyatomic anion. Okay, so the rule in calculating and determining the oxidation state in this case is like this. Okay, hydrogen. So hydrogen, there is only one atom. So it's gonna be like one atom, and then this is having a charge of positive 1. So before going further, guys, if we talk about oxidation state and oxidation number determination, we need to charges. Okay, not the valence electrons or not the electrons in the outermost shell, because those are very important, the valence electrons in the electron dot structures or in the chemical bonding. But we are not dealing here with chemical bonding. We are dealing here how to determine the oxidation state and the oxidation number. Okay. So 1. Okay. So this is all addition. There's no subtraction in chemical bonding, chemical reaction, or determining the oxidation number, oxidation state. Always keep that in your mind. There's no subtraction always. Always plus and addition. Okay? So plus, since you're looking for the sulfur again, algebra, we always treat algebra really, guys, in chemistry. We let X as the oxidation state or oxidation number of sulfur. So plus X. Okay? To make it easier, actually we can also plus sulfur. So we make it more specific, but we will just adopt the basics of algebra so that this will become a linear equation. Then we can solve for the value of X, which is automatically the value also of sulfur, oxidation number, or oxidation state. Right? So we have, okay mga palangga, nakita niyo ba ako? Diba? Okay. Hello! Shout out mga lanlan! Okay. So we have your plus. Again, 4, that is the subscript of oxygen. It will become the coefficient 4 times the oxidation state of oxygen is negative 2 times negative 2 is equal to. So since there is charge reflected at the top of the sulfate anion or polyatomic anion, then we need to equal this to negative 1. Okay, so our linear equation as of this moment, we have, okay, mga palangga nagsubay kayo. Okay, shout out sa akong mga friends out there, mga supporters. Okay, we are now live. Simultaneous FB and YT live streams. Okay, so we have one. Sorry for the space is very limited. I have only white, very small whiteboard, right? Okay, 1 plus x negative 8 is equals to negative 1. So x will be very simple math, right? Transpose the negative 1 there. So it will become x is equals to negative 1. Okay, then subtract this first in the left quantities. 1 minus 8 is negative 7. Okay, when you transpose that to the right, it will become positive 7, right? So plus positive 7, then minus 1 plus positive 7 is equals to 6. X is equals to 6. Since we let X as our oxidation number and oxidation state, then automatically that is our oxidation number and oxidation state of oxygen in the bisulfate polyatomic anion. Positive 6 is the answer here in number 1. Okay, the oxidation number and oxidation state of oxygen and bisulfate is 6. Okay, we answer already number 1. Erase. Okay, ganon. And now we go to number 2. Okay, guys, shout out mga kapatid. Shout out to everybody. This is your YouTube content creator. I am a singer Gina Voice. Okay, number 2. Calculate the oxidation state of hydrogen. It's hydrogen, guys. Sorry. Hydrogen in calcium. What's this? Calcium hydride. Okay? This is calcium hydride. You will never say calcium dihydrogen because this is ionic compound, not molecular compound. If you remember our vlog yesterday, there is a rule. Okay? So we need to be smart enough to identify first the type of compound is that because it matters a lot also. Now we have to solve for the value of H in calcium hydride. Okay, like that. Okay, so we have calcium belongs to column 2, which is the group number 2. So the charge is positive 2. Okay, so 2. Ganon. Plus subscript of 2 times hydrogen charge is positive 1 as always. Okay, like that. So equal to, now here you will be confused because there's no given charge up. That's compound or specifically any compound, then that is automatically 0. Okay, if there's no charge in the uppermost portion, that is equal automatically to 0. If we are dealing with the topic of determination of oxidation number and oxidation state. Okay, now equal to 0. Right? Now, since you are asking for H, okay, in this case, I assume